Hello. In this video we're going to be doing some trig on the coordinate plane. But before we get to the actual trigonometric portion, I want to talk about reference angles. A reference angle is an acute angle that's created by the terminal side of an angle and the x-axis. So in number 1 I have 315 degrees and I'm asked to find the reference angle. So if I draw a sketch of this, so there's my xy axis. The initial side lies in the positive half of the x-axis, and 315 is going to rotate into the fourth quadrant. There's 315 degrees of a rotation. So the reference angle is the angle created with the x-axis and the terminal side. So this is our theta of a rotation, and this is what we call theta prime, and so it's describing the reference angle. And so how many degrees is that? Well, we've gone 315. It's 360 for a full circle, so 360, take away that 315. Here our reference angle is 45 degrees. Let's look at number 2. In number 2, we have negative 150. And so again, I'll draw a picture here. And we're on the positive half of the x-axis for the initial side. Negative 150 means we're going to travel clockwise instead of counterclockwise. It's not quite a half a circle, it's a little less than that. So we're right there. And so that's our theta. And so this time, our reference angle is made over there with that part of the x-axis and the terminal side. And so that's our theta prime. And again, we went 150 degrees, and it's 180 to make a half circle. So 180, take away the 150 that we went, and it's 30. So our reference angle here is 30 degrees. Okay, our reference angles are always going to be positive, and they're always going to be between 0 and 90 degrees, or in radians between 0 and pi over 2. So in the third one, we have an angle in radians, and it's 4 pi over 3. And so let's take a look at what that appears to be. And so there is our coordinate plane. There's the positive half. 3 pi over 3 will land me there, because that's 1/2 of a circle at 1 pi. 4 pi over 3 is going to get me into the third quadrant, down here somewhere. If I go 1/3 of that bottom half of the circle, so there's theta, and our reference angle is over here again. It's made with the terminal side and the positive half of the x-axis. And so this top part was 3 pi over 3. So if we have our 4 pi over 3 rotation, but we take away the half of a circle, or 3 pi over 3, we get just 1 pi over 3. And so that's our reference angle, is pi over 3. All right, and so that's what reference angles are. Let's look at something else. Consider an angle theta in standard position with x comma y as a point on the terminal side, and r being the distance from the origin to x comma y. And so I'll just draw a general sketch of this. So I have the positive half, or the initial side, still sitting on the positive half of the axis. And then I'll rotate over to wherever x comma y is. And I don't know, we'll just put it over here, I guess. And so we'll say that x comma y is sitting right there. Now r is our distance from the origin to x comma y, so that length right there will be r, that segment. And then what I can do is drop an altitude down to create a right triangle. And what is the length of the legs of these right triangles? Well, to get to the point x comma y, I had to go left x units, then I had to go up y units. And so what we can do from here, knowing that our reference angle, right there, theta prime, okay, we can use that, if this is our theta, there's theta prime drawn inside the triangle. And so we can find all 6 trig ratios of theta using the reference angle. So Theta prime, if we do opposite over hypotenuse for sine, that is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we can do the reciprocals for each of these. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Okay, you should definitely get this in your notes. This will be applicable for us for the rest of the year. Let's practice this. So let 5, -12 be a point on the terminal side of theta. Find all 6 trig ratios. So I'll draw a sketch again. 5, -12 lands me down here. So here's my initial side. There is, I'm going to try to go through the point that I drew. There we go. Now, I don't know which way I rotated, if I went clockwise or counterclockwise, how many times I went around, but I do know that this right here is my reference angle. And again, I can drop or bring an altitude in to create a right triangle. I went over to the right 5. I went down -12. And then we need to find r. What's the hypotenuse? Well, this is a 5, 12, 13 triangle, because 5 squared plus 12 squared would equal 13 squared. And let's do our trig. So sine theta. Opposite over hypotenuse. Opposite is -12. Hypotenuse is 13. Cosine, adjacent is 5, hypotenuse is 13. Tangent, opposite is -12, adjacent is 5. And then the reciprocals. Cosecant of theta is 13 over -12. Secant is 13 over 5. And cotangent is 5 over -12. Okay, and so that's how we do some trig on our coordinate plane. We use reference angles. We will use more of this in class. For now, we're done.